In this video, I discuss annuities. This is the outline for my presentation. I will start by defining what annuities are, and then in our discussion, I'll move on to annuity immediate, and finally, I'll end with annuity due. So what is annuity? An annuity is a series of payments made at regular intervals. Payments can be made weekly, monthly, annually, or etc. So any kind of payments or series of payments you can think about where you are making regular payments at regular intervals, you can term that series of payments as an annuity. So some examples of annuities in financial transactions are: 1, a loan repaid with equal monthly installments. Typically, when you go for a loan from a bank, you may be required, according to the contract, to pay back the loan, pay a portion of the loan on a monthly basis or at the end of every year until you are done paying the full loan that you have taken. So because you are making regular installments in your efforts to pay off the loan, we will term that activity of making the regular installments as an annuity. Those payments are termed as an annuity. It could be on a monthly basis, it could be on a yearly basis. Another example is a retiree purchasing an annuity from an insurance company upon retirement. So in this example, when you retire, or if anybody retires, you can walk into an insurance company and then give them your retirement amount or your sum, the lump sum you've been given as your package for your retirement in exchange for an annuity. So what this means is that you were given probably $1 million as part of your retirement package. You can hand over this $1 million to an insurance company, and then they will estimate how many more years you are likely to live. And then at the end of every month, they will give you some amount of money, which should be way lesser than the $1 million. But you are giving them your lump sum in exchange of regular payments you will receive over your lifespan, over the remaining years that you have to live. The third example is a life insurance policy purchased with monthly premiums. Usually when we purchase an insurance package, especially for me in my country, what I realize is that you have to make the first payment for the insurance coverage to take effect. And thereafter, you will always make payments. If, let's say, you have signed on to an educational fund policy and you're supposed to make payments an amount of money, $500 every month, when every month comes, at the end of every month, you're required to deposit $500 into that insurance account to be able to sustain the insurance contract you have with the insurance policy. Another example is a lease or a rental payment. So in this discussion, we consider annuities with level payments, which means that the payments you'll be making will be the same amount over the term of the contract. So we consider annuities with level payments, all of which are assumed to be certain. There is no default risk assumed for this annuity. So in this course, in this particular topic we are treating, we are making these assumptions. Payments will be the same amount of money. The payments will happen. Nobody's going to default. Okay, so these are the three assumptions that we have made. Now, in annuities, we have time value of money. That is, you may want to consider the present value of an annuity or the future value of an annuity. The present value of any stream of payments is the current width of future payments. And then the future value of any stream of payments is the value of payments at a future date. Why is this relevant? It can be relevant in budget planning for long-term contracts, Also, you can evaluate cost effectiveness of equipment leases. If you are engaged in a contract where you want to lease an equipment, your present value or future value can help you to know how cost effective it is to do that lease agreement. Now, we move on to the first type of annuity, which is the annuity immediate. An annuity immediate involves regular payments made at the end of each period, commonly known as an ordinary annuity. So what are some examples of annuity immediate? Monthly installments for purchasing equipment. So for example, if you go to purchase equipment and you're allowed to pay it over a period of time, you would the agreement may be such that you will make a payment at the end of every month for that particular equipment. Also, another example is quarterly maintenance service payments. So once again, you may contract a service provider to take charge of maintenance of your equipment in your company. And once you are doing that, and the agreement is such that you make payments at the end of every quarter, it then means that at the end of every quarter, you have to make a payment. So in this case, payment is being made at the end of the period. Now, this is a time diagram for an annuity immediate. In this time diagram, we can see a line and then some numbers. Let's assume these numbers to be years. So we assume these numbers to be years. So what is happening here is that at the end of year one, a payment of $1,000 is made. At the end of year two, a payment of $1,000 is made. At the end of year three, a payment of $1,000 is made. At the end of year four, and then also at the end of year five, payments of $1,000 are made at the end of each of these years. Now you can see here that these payments are level. It's $1,000, $1,000, $1,000 for at the end of each year. The value we see here is the future value of these amounts. So for this particular $1,000 that was paid at time 5, the value is 1,000 cedis at time 5. Now this 1,000 cedis paid at time 4, the value is 1,050 at the end of year 5, simply because there is an interest of 5% being paid. We will go into this discussion as we proceed in this lecture series. So typically, this is how a time diagram for an annuity immediate looks like. Payments are made at the end of the period. Now, there is a formula for calculating present value of annuity immediate, and the formula is provided on the screen. So the present value of an annuity immediate is equal to P times, open brackets, 1 minus, open brackets, 1 plus I, close brackets, to the power minus N, all over I, close big brackets. What do these variables mean? P is the payment per period. So in the example we saw here, P is this 1,000 cedis. Okay, P is 1,000 cedis. Now, I is the interest rate per period. In this example, we have I to be 5%. N is the number of payments. In this diagram, we see that there were 5 payments, 1, 2, 3, 4, 5. How do you apply present value of an annuity immediate? To determine current costs of facility leasing, analyzing long-term financial commitments. Now let's look at this example. A manager pays $10,000 annually for 5 years for maintenance services. The annual interest rate is 7%. We want to attempt to find the present value. Now, referring to the formula for present value, our present value under annuity immediate is equal to P times 1 minus 1 plus I raised to the power minus n all over I, and close your brackets. So in this example, the manager is paying 10,000 annually for 5 years. So P is 10,000. N is 5. And then I is 7%. Once we've been able to identify our variables and the numbers associated with these variables, we just fix them in the formula, and that's what we have here. So P 10,000 is here. 1 minus 1 plus I, 1 plus 0.07 is 1.07. So we have that here. Raise the power minus n, which is 5, all over I, which is 0.07. So once we are able to fix all these in, you can use your calculator to calculate this. And then whatever value you get, you multiply by the 10,000 to give you a final answer of 41,001.89. So by interpretation, the present cost of future obligations for accurate budgeting. In this case, if the manager is paying 10,000 cedis annually for 5 years of maintenance services, this manager can know from today if he's going to make these payments in the next 5 years. He can estimate that for me to make $10,000 of payments at the end of each year for the next 5 years, I will need to have 41,001.89 today. So that is what present value means. What should I have today so that I can make some future regular payments and be able to make those payments? So for this manager to be able to pay 10,000 cedis every year for the next 5 years, he would need to have $4,001.89 today. Now let's look at the future value of annuity immediate. The formula for calculating the future value of annuity immediate is FV, which is the shorthand form of future value, equals P times 1 plus I to the power n minus 1 all over I. This P, once again, is the regular payment you'll be making. The I here is the interest rate, and the N here is the number of, or the term of the contract. So future value can be used to project the cost of facility expansions. It can be used for future budgeting for equipment, replacements, and many others. Now let's look at an example. A facilities manager plans to invest $8,000 annually into an equipment replacement fund. What will be the total accumulated amount at the end of 6 years if the fund earns an annual interest rate of 5%? How much is he investing at the end of every year? $8,000 into an equipment replacement fund, which means that the manager has opened the fund, and we want to know what will be the total accumulated amount at the end of 6 years if the fund earns an annual interest rate of 5%. So very importantly, you need to identify your variables in the question. The annual investment he's going to be making is P, which is equal to $8,000. Interest rate here is 5%, and the duration is N, which is equal to 6 years. So once we are able to figure all these out, we simply pick the formula for calculating the future value, which is future value equals 1 plus I to the power n minus 1 all over I. There's supposed to be P here times everything here. So the P here is 8,000. Then we have 1 plus I, which is 1 plus 0.05, so 1.05. And then we have to the power n, which is 6, minus 1, all over I, which is 0.05. So once you're able to fix this in, first of all, input this one into your calculator. Whatever you get, multiply by 8,000, and that should give you your final answer. So here we have for this fraction, we have 1.05 to the power 6 minus 1 all over 0.05. And that's giving us 6.8019. So 6.8019 times 8,000 is giving us 54,415.3. So this is the final answer this is the future value of paying 8,000 at the end of every year for the next 6 years at an interest rate of 5%. We move on to annuity due. An annuity due involves regular payments made at the beginning of each period. It contrasts with annuity immediate because in the case of annuity immediate, payments are made at the end of a period. Examples of annuity due or examples of contracts where annuity due comes to play is lease payments for office spaces. Typically, when you go to rent an office space, you will have to make payment before you can have access to the space. So you sort of make payments at the beginning of every period, because if you make payments at the start of the contract, once the contract ends and you want to renew, you'll have to make payments again before you can have access to use the facility. So lease payments for office spaces are a typical example of a case where annuity due is demonstrated. Now, this is a time diagram for annuity due. In this example, or in this time diagram, we see that the level amount being paid here is 5,000. Now, it's being paid at the beginning of every period. This is period 1, from 0 to 1. The 5,000 is being paid at the beginning of the period. Now, this is period 2. 5,000 is being paid at the beginning of the period. So you pay 5,000 or the level amount at the beginning of every period. There are 4 periods being considered here. So this is how typically a time diagram for an annuity due looks like. Now, what is the present value and future value of an annuity due? We will pick it from annuity immediates, and then we will find out what the formula will be for annuity due. The present value for annuity due is simply the present value of annuity immediates times 1 plus I, which is that an accumulation factor, sorry. And then the future value of annuity due is the future value of annuity immediate times 1 plus I. So we are saying here that each payment in annuity due is 1 period earlier compared to annuity immediate. Let me demonstrate it here. Now, in this timeline, what do we see? The timeline in the blue color is ordinary annuity or annuity immediate. And then the timeline in the orange color is annuity due. Under annuity immediate, we see that payment is made at the end of every period. But under annuity due, payment is made at the beginning of every period. Each of them are making payments. There are 5 payments in all. There are n payments in all. Sorry. 1, 2, 3, 4, all the way to n. Okay. 1, 2, 3, 4, all the way to n. But for the immediate, I repeat, payment is being made at the end of the period. And for due, payment is being made at the beginning of the period. We just saw how to find the present value of annuity due. So I'll say present value of annuity due. And this is equal to present value of annuity immediate times 1 plus I. How is this so? The present value of annuity immediate happens at this point. It happens at this point. Here. Now, if it is happening at this point, it means that it is happening one period before payment starts. Present value of annuity due, annuity immediate is happening at this point. And this point is indicating one period before the first payment takes place. Now, present value of annuity due is here. Now, this present value is happening at the time of the first payment. Annuity immediate, it's happening one period before the first payment. Annuity due is happening at the time of the first payment. So if I want to know this and I have this, I just have to move this here. Then I have the present value of annuity due because the present value of annuity due happens at the time of the first payment. At the time of the first payment. That is how come the present value of annuity due is simply equal to the present value of annuity immediate times 1 plus I. 1 plus I is that compounding factor that takes you to the next period from our lesson on interest theory. So I hope this makes sense. Now, the future value of annuity due is equal to the future value of annuity immediate times 1 plus I. So once again, the future value of annuity immediate happens at the time of the last payment. But the future value of annuity due happens one period before The future value of annuity due happens one period after the last payment. One period after the last payment. So if I know the future value of annuity immediate, I only have to move forward by one more period, n plus 1. And then I'll have the future value of annuity due because it must happen. Future value of annuity due happens one period after the last payment, as indicated here. This is the last payment, it's happening one period after. So once I have annuity immediate and I move it just one period after, I can find the future value of annuity due, or it becomes the future value of annuity due. Now, here's an example on annuity due. A company needs to pay annual rent of $15,000 at the beginning of each year. What is the present value of these payments over 5 years, given an annual interest rate of 6%? This is how the payment stream looks like. We are looking at five periods of payment. So 0, 1, 2, 3, 4, and then 5. The company needs to pay 15,000 at the beginning of each year. So the company will pay 15,000 at period 0, 15,000 at the beginning of period 1, 15,000 at the beginning of period 2, 15,000 at the beginning of period 3, 15,000 at the beginning of period 4, and then 15,000 at the beginning of period 5. The interest rate involved here is 6%. Now we want to know what is the present value of these payments over 5 years. So what I'm going to do is, first of all, identify the variables in here. P is 15,000, which is my level payment. I is 6%, which is my interest. And then N is 5 years, the period we are talking about. I will first of all find the present value of annuity immediate, and then I will use that to find the present value of annuity due, which actually is what the question is asking for, because the question is saying that the 15,000 is being paid at the beginning of each year. So by the formula of present value of annuity immediate, we have it to be 1 minus 1 plus I to the power minus n all over I. So 1 minus 1.06 to the power minus 5 all over 0.06, and that should give you 4.2124. Once I have this, I bring it here and then I multiply by 1 plus I, as we saw previously. So if I do this, this value now becomes the present value of annuity due, which is the required case for the question. Now, this was solved in the case where P is equal to 1. So once we have this, P is not 1, P is 15,000. So we have to pick this, multiply by the 15,000. And then finally, we have the present value of these 5 payments of 15,000 at the beginning of each year at a rate of 6%. It is given to us as 66,976.50. So this is the end of our discussion on present. This is the end of our discussion on annuities, considering annuity immediate and annuity due.